Hey, what's up, guys? Catlin here, helping out with lesson 15. I just realized I didn't have this one posted from last year, so I wanted to make a quick video to show you how to find these solutions when you have an irrational answer. The square root's going to pop up as we complete the square. All right, so we've got our equation here, and we have the answers we could get if we just plugged it into the graphing calculator. But those answers aren't going to be good enough for you for ACT or a test that has the exact solutions, because the exact solutions are going to look like a square root added or subtracted by something. And so we're going to go through, as I cough, sorry, we're going to go through how to do this by completing the square. All right, so uh, the first thing we need to ask ourselves is, what do we want to be the constant term if my middle term is 14x and I've just got a regular x squared? So that makes this really easy. Like, what would be the perfect squares last terms multiplied if we did that? Well, we know the trick is we have to cut the 14 in half, which would give us 7, and then we have to square that. So 7 times 7 is 49. We want a 49 in that spot. That's our goal. So to make that happen, what we're going to do is we're going to add 49 to both sides. We add 49, not a 9. We're going to add 49 to both sides. So add it to the left, and we get 49. And then on the left, we had negative 46. So if we add 49 to that, then we would get a difference of 3. Positives winning by 3, right? So that's what that ends up being. So our next step would show, all right, we got our perfect square now, because this would factor out to x plus 7, which we're about to write here in a second. These add up to be 3. All right, so we've done our first step. We've completed our square, and now we have to go through our solving process. So let's go ahead and do on the left. Let's factor this. We picked 49 because we knew that 7 times 7 was 49, and that's the factor part. If we multiply that binomial out, we would get this standard form, and we are just factoring. Excuse me. So that doesn't affect the 3 on the right. All right, so now we've learned that we can take the square root of both sides to get rid of this square here. But when we take the square root of this 3, something happens different than what we've seen in the past. We don't know what the square root of 3 is as a whole number because it's irrational. It comes out as a really long decimal point that goes on forever and ever. And so what we do here is, instead of approximating that and writing out the number like the calculator does to get these answers, right? That's essentially what it does. What we do is we just leave it as root 3, square root of 3. And then we work the problem out using that. But it's not just the square root of 3, it's also the negative version of whatever the square root of 3 is, right? So what we've learned that we can do today is we can take x plus 7, which is what happens when you unsquare a square, right? And then on the right side, we know that it's going to be a positive or a negative square root of 3. And that's going to be our answer so far. Now we're one step away from having x by itself, right? So if x was by itself, the 7 would not be here. So we need to take 7 away from both sides. So if we take 7 away from the left side, that leaves us with the x by itself. And if we take 7 away over here, then that would put a negative 7 there, plus or minus root 3. And there's our answer. And essentially what this means, if you're not understanding, like, oh my God, my answer looks like that. Yes, it does. So the answer means that x could be, okay, negative 7 plus or minus, could be plus, okay, here's the plus version of adding root 3, or it could be x equals negative 7 minus. What is wrong with my brain? Minus. Okay, so minus square root of 3. These are the two ways this could work out, right? And guess what those equal when you do those things in the calculator? This is when I add root 3, and this one right here is when I subtract it. That's what it would come out to be. And that's why the calculator is giving you those numbers. But those numbers actually go on forever. Check it out. If I go here and do negative 7, let me clear all this out. If I take negative 7 and I add the square root of 3, you'll see that I get that number that we saw, right? But it goes on longer because this calculator goes more decimal places than the graphing calculator does. And then if I subtract root 3, you'll notice that these are the two answers that we're getting, but they're cutting them off. That 7 becomes an 8 because of that 9, and that 2 stays a 2 there. right? You see those two numbers with three decimals on the graphing calculator, but this is a better approximation here. But in fact, those decimal goes on forever. So this is the exact answers that we want, not the approximated ones that are given um, by the graphing calculator. Okay, so the best way to write this, and simply, is just like this, which means those, and they turn into these things, right? But that's how you do these exact solutions, guys. It's not that bad. Okay. I know it can get more complicated when there's coefficients in front of that x squared term. All right. But not something I'm really concerned about you being fantastic at yet. You'll get more practice with that, I believe, when you take Algebra 2. All right. So long from Mr. Catlin. I hope this is helpful, and good luck practicing.